Hi, I'm Dylan with the North Shore High School Mu Alpha Theta Math Honor Society, and today we will be looking at IB probability. Now, probability is essentially the chance or likelihood that any given event will occur. An event is anything that you can think of, flipping a coin and having it land on heads, rolling a die and having it land on any of the numbers, the sun rising. Anything can be considered event, and probability is just the chance that that event happens. So the first thing that we'll go over is the way in which you write all of these things down, the format that you have to write, and the symbols that IB uses so that you can understand what's going on. So if you had an event, let's call it event A, right? And you wanted to know the probability of that event, the way you would write that down in IB is probability, big uppercase P, and then parentheses A, parentheses. The way that you would read this is the probability of A. If your event was, say, flipping a coin and having it land on heads, you could just write probability of H for heads, and then off to the side write let H equal the probability of flipping a coin and having it land on heads. Unless this is given to you in the problem already, it is safe to use that let statement to alert the IB graders about what exactly you're taking the probability of to avoid any sort of confusion. So now, this is the probability for a single event. Let's say you wanted to do the probability for two events. You had events A and events B. So you could do this in a few different ways. The first way is if you wanted to know the probability that both A and B happen. The way that you would write that is probability of A and B. That's how you would say this, the way I just said this when I was writing it there. The probability of A and B. This symbol here represents intersect. It kind of looks like an upside down U, or kind of looks like an N. That's how I remember it. Probability of A and B. The N and you can remember it however you like, but it means that it's the probability that both A and B occur, both events. There's also the probability of A or B. You have this U symbol here. This U symbol here is called union. You could also read this the probability of A union B. And this just means the probability that either A or B happens. If one of those two things happens, this is satisfied. So the probability that either or happens. And the last way you can have two different probabilities is probability of A given B. This is what's known as conditional probability. This line here represents given, is how you would speak it, and it represents conditional probability. What this means is that if two events A and B have an influence on one another, then you would use this sort of probability to say, what's the probability of A if I know that B has already happened? And like B actually did happen. So say B was the probability of a coin flipping and landing on heads. Given that the coin flipped already landed on heads, or would land on heads, what is the probability then of A? This comes into play when you're talking about two events that would affect one another. Like, say, the probability that you studied versus the probability that you got a high grade on the test. Those two events would affect one another, and you would use that in a situation like this. So these are the three different ways you can write down sets of two different events. And knowing this notation will really help you out understanding everything that you need to know. Just remember, this is the probability of A and B, this is probability of A or B, and this is probability of A given B. We'll go into that in a little more detail coming up. So now what we're going to do is go over the different types of probabilities with two different events that IB looks at. So the first type is what's called combined events. This is just your basic two different things happening. type of probability. So, for instance here, we'll look at if you flipped a coin and had it land on heads, and if you rolled a die and had it land on the number 1. Those will be our two events that we'll think about to help us understand combined events. So the most important thing that you need to know for combined events in the IB is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is one of the most important things to know for combined events with IB probability. And the reason for this will probably help you to remember this, is that for the probability of A or B, you want to count everything just once. So say, with our coin flipping and die rolling example, the probability that it lands on heads, that could happen. There's the probability that the die, you roll a 1, that could happen. But then there's also the probability that both, I'm sorry, I wrote the wrong symbol here. I said the right thing, but I wrote the wrong symbol. It's the probability of A and B. There's also the chance that both A and B happen at the same time. If you included that probability, you would double count for this probability, and you get a number too high, so you just want to subtract that out. So, for our flipping a coin and rolling a die probability, how could you go about finding the probability of flipping a coin and having it land on heads, and rolling a die and having it land on the number 1? Well, first, we know that flipping a coin and having it land on heads is 1/2, because there's two sides of a coin, it'll only land on heads or tails, so we know that it's going to be 1/2. Similarly, for a die, there are 6 faces on a die, so the probability that it lands on 1, assuming the die is fair, is 1/6. So, we run into a little bit more trouble with finding the probability of A and B, but one of the ways that we can do that is by making what's called a tree diagram. So, what you do for a tree diagram is you start at a point, right? And you go through your first event, flipping a coin. Now, if you flip a coin, you can either get heads or tails. So you draw 2 branches of the tree like that. Then you go through your second event, the probability of rolling a die and getting a 1. So if you roll a die, you can get 6 outcomes. 5, 6. And those outcomes are 1, 2, 3, 4, 5, and 6. Similarly, here you would do the same thing. You can get a 1, a 2, a 3, a 4, a 5, or a 6. Now what the tree diagram does is it captures all possible outcomes of your 2 combined events, because it captures if you got a heads or tails, and then from there, what number you got on the die. So this last row here will contain every possible outcome of these 2 events. So if you count up the number here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 possible outcomes here. And how many of them have both the probability of flipping a coin and rolling heads and landing a die roll on the number 1? Well, first you go up through the heads, and then you get to the 1, and you'll see that only 1 of the 12 branches contain both of those. So the probability of both is 1/12. So with this information, we can just simply do this math and see that the probability of A or B is 1/2, which is 6/12, plus 1/6, which is 2/12, minus 1/12 is 7/12. It's important to note that this can also be used the other way, you can rearrange this equation to write the probability of A and B is equal to the probability of A. Let me write that a little nicer. The probability of A plus probability of B minus the probability of A or B. You can get to this by simply rearranging this algebraic equation here, adding A and B to both sides and subtracting A or B to both sides. This is more rarely used though, but you could find that it will come in handy at times. So, the next type of event that you will see are mutually exclusive. So mutually exclusive events are essentially if you have two events, A and B, only A or B can happen at the same time. So what this means is that, say, let's take an example. The probability, let's say A is the probability that someone is a junior, and B is the probability that someone is a senior in high school grades. What is the probability of A and B here? Obviously, 0. No one can be both a junior and a senior. They're one or the other. What this means is that if you have mutually exclusive events, the probability of A or B is just the probability of A plus the probability of B, because the probability of A and B is always 0 for mutually exclusive events. And that's the main thing that you want to remember with mutually exclusive events, is that the probability of A and B is equal to 0. That is the most important takeaway here. So anytime that the probability of A and B is equal to 0, you have mutually exclusive events. Now, the next type of event is kind of a step above mutually exclusive events. They're called exhaustive events. So an exhaustive event means that if you have two events, say event A and event B, the probability of A or B is 1. So these two events, either one of them must happen. What this means is that, so for example, take, if you're flipping a coin, the probability, say A is getting heads and B is getting tails. What's the probability of getting heads or tails? 1. It has to happen. So for mutually exclusive events, or I'm sorry, exhaustive events, the probability that either happens is always 1. Now another thing about exhaustive events is with what is called complementaries. So you have A, right? But then you can also have not A. We write this as A with a little subscript C up at the top. So for example, if A is the probability you flip a coin and it gets heads, C is the probability that you flip a coin and it is not heads. The probability of A or not A is always 1, because something either has to happen or not happen, and there's no way really around that. So again, the probability of A or B is just 1 here with exhaustive events. And the probability of A and not A is also going to always be 1. A and not A. Not A is called its complementary. I'll write that down. Will always happen. So try to remember that for exhaustive events. The probability of A and not A will always happen. The next type of probability is what's called conditional probability. So conditional probability is where this given symbol comes in. Again, A given B. Conditional probability is something that you'll see a lot on the type of questions that IB like to ask. And a lot of times you'll see it in the form of either a tree diagram like we saw before or like a table. And I'll demonstrate this one with a table because we haven't seen it before. So, let's say on this table we have grades on this side. We'll use junior and senior again. And up here we have sports. Let's say baseball and football. So we have numbers in this table. Let's just say 2, 3, 4, 5. This is a really simple one for the sake of example. What this means is that there are 2 juniors who play baseball. There are 3 juniors who play football. There are 4 seniors who play baseball, and there are 5 seniors who play football. The way conditional probability would work is, let's say B is the probability that you play baseball because it's already B, and A is the probability that you're a senior. So the probability of A given B would mean the probability that given you play baseball, you are a senior. So what that means is we will look only in this B category because the given information is that we play baseball. Now, of the number of people who play baseball in total, there are 6. The amount of them who are seniors are 4. Therefore, the probability that you are a senior given that you play baseball is 4 out of 6. And that's what that means. You can also do this with rows as well. Let's say B is the probability that you're a senior and A is the probability that you play football. So the probability that you play football given that you're a senior, for that we would look exclusively at this row here, this row here, and the total number of seniors is 9. The amount of them who play football is 5. So the probability that you play football given that you're a senior is 5 out of 9. And that is how conditional probability works. We will go over more in-depth example of that when we look at problems. So one thing to know about conditional probability is that this equation, the probability of A given B, equals the probability of A and B over the probability of B. Let's just do a quick demonstration with this to show you how you would use it. So let's go back to our original example where B is the probability that you play baseball and A is the probability that you're a senior. So the probability of A and B, the probability that you're a senior who plays baseball. What you do for this is you go to here, 4. So if you're a senior who plays baseball, you're 4 out of the total here. The total here is you add everything up in the table. Sometimes there will be total rows. That makes it easier to get the total, but you would not add those up here. For this, we're adding them up because there are no total rows. So 2 plus 3 is 5, plus 5 is 10, plus 4 is 14. So the probability that you're a senior who plays baseball is 4 out of 14. And then the probability that you play baseball is So there's 6 people who play baseball out of the total 14. So you divide that by 6 out of 14, and that equals 4 out of 6 because these 14s cancel out, and that is the same as what we got before. So that is how that works. And the last type of thing that you need to know before we can begin to look at practice problems is independence. Oftentimes, probabilities will not have an effect on one another. For example, going back to the coin flip and the roll of the dice, what you get off your coin flip will not affect what you roll on your die. Therefore, conditional probability won't really work on it, because the probability of A given B for independent events A and B is just the probability of A. And that's often a way that you can test if something is independent, is if the probability of A given B is equal to the probability of A. So, a couple things that you need to know are that mutually exclusive events are never independent, because mutually exclusive events, either A or B has to happen. So if A doesn't happen, then B must happen. That means they have an effect on one another. If two probabilities have an effect on one another, then they are not independent. So that's something important to keep in mind. Mutually exclusive is not independent. So that is something IB will ask about occasionally. Just keep that in mind. Mutually exclusive events can never be independent, and the same vice versa. They are different. Okay, so now that we've got all that, we'll look at a couple of practice problems. So the first one I have here reads, in a research project on the relation between gender of 150 science students at a college and their degree subject, the following set of data is collected. And here we have a table like we had before. So, with this data and with this table, they could ask you a whole variety of questions, mostly about conditional or non-conditional probabilities. One of the questions that they would ask you could be, what is the probability that a male person is studying biology? So that's the wording of that is important. The probability that a male is studying biology. That a male implies conditional probability that you're given male. So that means it's the probability of biology given male. And the way that you would go about doing that is we have our equation from before. This is equal to the probability of biology and male over the probability of male. So, the first thing that you'd have to do in going about solving this problem is find the various totals. So the total number of people studying biology is 55, 40 plus 15. The total number of people studying physics is 40, and the total number of people studying chemistry is 55. The total amount of males in the class is 40 plus 35 is 75, plus 16 is 91, and the total number of females is 35 plus 24 is 59. This means that the table total is going to come out, as it says up here, to 150. If you add it this way or this way, it should both times come out to 150. So, knowing this, we can very easily go about answering this problem. The probability of biology and male is 40 out of the total 150. So we have 40 out of 150, and that's divided by the probability of being a male. So that's 91 out of 150. 91 out of 150. The 150s cancel out, and you're left with 40 over 91, and that is the probability of studying biology given that you're a male. Now, it's important to remember that the way they could word that question is, what is the probability that a man is studying probability? The wording of these questions is important, as oftentimes it will imply a conditional probability within the wording without saying given or things like that. You have to be on the lookout for that. They could also ask something easier, or per se, just like, what is the probability that a randomly selected student is female? That's something you'll see asked often, and this is why doing these totals makes it very easy, because you can just do the total number of females is 59 over the total number of students is 150. So those are generally the two types of questions that they will ask about something like this. Another type of question that you could get is like this one here. So this question reads, a 6-sided die numbered 1 to 6 and a 4-sided die numbered 1 to 4 are tossed at the same time. Represent the sample space on a grid. So the sample space is all of the total possibilities, like we showed before with the tree diagram. The way you would represent it with a grid is like this. So you have your die, and that can have possibilities 1, 2, 3, 4, 5, or 6, and then a 4-sided object 1, 2, 3, 4. Now here you can just draw a grid separating into spaces all of these different sections, and each square here represents one possible outcome. It's a little small for me to write it here on my computer, but you understand you can either get a 1 and a 1, so this box is 1, 1. You can get a 2 and a 1, so this box is 2, 1. Another way you can do this is to write the totals in the boxes. You can get a 2, you can get a 3, 4, 5, 6, 7 by adding the numbers you get here. You can get 3, 4, 5, 6, 7, 8 by adding the numbers on these sides here and here. You can get 4, 5, 6, 7, 8, 9 by adding the numbers here and here, and similarly you can get 5, 6, 7, 8, 9, 10. So this is how you would represent the sample space on a grid. Now here it asks 3 possible questions. When tossed once, what's the probability that you will get a 4 and a 1? So there are 2 ways that you can get a 4 and a 1. You can get a 4 here and a 1 here, or a 4 here and a 1 here. That means there are 2 possible ways that that could happen. Out of the total ways, you can just multiply the rows by the columns here in this chart. So you have 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. 6 times 4 is 24. So it's 2 out of 24 possibilities. Now here it asks you, what's the probability you get a sum of 7? Well, because we did this sum chart here, you can just look and see how many times you get a sum of 7. 1, 2, 3, 4. So a sum of 7 will happen 4 out of the total 24 possible times. And here it asks a sum more than 7. So similarly, we can just count 1, 2, 3, 4, 5, 6 out of the total 24 numbers are higher than 7. And that wraps up this video on probability for IB Mathematics SL. Thank you very much. I'm Dylan McGinley. Have a great day.